Okay, let's learn how to graph quadratics. Okay, this is quadratics video number 1. I was going to do 2 videos, but this will just be, I think, 1 long video, and then I'll make another one for next week. So, quadratic functions. Quadratic functions have an x squared in them. We've done a lot with linear functions, but we just started working with expressions that have exponents or powers. So now we're going to be looking at quadratic functions. Y equals x squared is called the parent function. That means it's the basis for every quadratic function. Always has an x squared in it. Specifically today we're going to be looking at vertex form. So vertex form is written in a certain way. There's always an x squared or a parentheses squared, and then there's some other numbers involved. So there's always an x squared or a parentheses. Vertex form always has x squared or parentheses squared. Okay. So some notes about vertex form. This is our first slide of notes. I have 4 slides and then some examples. So when we write it, if you notice, I took all the numbers from before I had these numbers. Let me get my highlighter. I had a 2 in front. I had this -3 in the end there, or in the middle. I had a +1 at the end. Those numbers tell me something about where the graph is located. And so here's where I'm going to use these letters A, H, and K. Those all represent numbers. I'm just telling you that this is called vertex form because the numbers that go in the spots for H and K, those numbers are the vertex. So let's look at what some graphs look like so you can see what a vertex is. Okay, so I'm going to graph the parent function over here to the left, y equals x squared. This is a quadratic function. We call this shape a parabola, and it goes down and goes up. It increases and decreases. I can flip it over by putting a minus sign in front. So if I graphed y equals negative x squared, it gives me an upside down one. So my blue graph right there is y equals negative x squared. So anytime there's a negative in front of the function, it flips it upside down. It reflects it. Get my original parent function back here. So this point at the bottom is going to be the point, I'm going to plot a point 0, 0. Pressing the wrong button. 0, 0. So it's in green. This point in green, that's my vertex. That's the vertex of the graph. Now, if I put different numbers in this equation to match this, okay, if I put a number in for A or a number in for H or a number in for K, that's going to change where my vertex is. Okay, so here's my graph. So right now my vertex is at 0, 0. If instead of a parentheses, or instead of an x, I have a x parentheses. Let's see what happens if actually before I do that, let's just go back to x squared. Let's see what happens if I just add something to the graph. If I just put a +3, what happens to my graph? Okay, well, it moved. Where is the new vertex? What point is this? It's 0, 3. My new vertex is at 0, 3. So if I didn't have the +3, my vertex was at 0, 0. If I put a +3, my vertex is at 3. If I put a +5, my vertex is at 5. The whole graph is still there, but the vertex is at 5. So back to my parent function. If I want to shift my graph down, like if I want to go down to -2, I subtract 2 from the graph, and there's my vertex, 0, -2. If I wanted to go all the way down to 10, I would do -10. Now I have to move my graph a little bit and see it. Now my vertex is all the way down at -10. So let me show you on our notes where you can write something about that. This is actually slide fourth slide. So this number k at the back, I'm going to put a circle around it. Okay, this k at the back tells you how much you move your vertex up or down. So if I have x squared plus 5, that means I move up 5. If I have x squared minus 5, that means I move down 5. So you need to know that. Having a number at the end plus k, it could be at the beginning as an added problem like 5 plus x squared. That's the same as x squared plus 5. That's still going to move my graph up or down. If it was 5 plus x squared, it would still move it up 5. Okay, again, to see that on the graph, if I want to move it x squared plus 5, here's my x squared. Oh, I gotta go back. Here we go. Here's my x squared. And if I wanted to shift my graph up 5, I put a plus 5. So that's probably the easiest of the three numbers that we're going to look at, is that if we put a number at the back of it and we do a plus 5, it goes up 5. If we do a minus 5, it goes down 5. And like I said, that's probably the easiest of the three letters, A, H, and K. And you can go back and pause the video if you need to. Now let's see what happens if we put a number on the inside. So we're going to look at this H letter. So I'm going to get rid of the plus 5. Notice I'm starting back at 0, 0. Here's my vertex 0, 0. I'm going to put parentheses around the x, so I can put some numbers on the inside. If we look at our picture on the notebook file, it's inside parentheses, right? The H is inside the parentheses, so we're looking inside there. So if I go inside the parentheses, and it said x minus h, so let's say I plug in minus 2. It actually went to the right 2 units. If I plug in x minus 5, my vertex is now at 5, 0. It went to the right 5 units. If I plug in minus 3, it's now 3 to the right. So again, if I start at 0, it's just x squared minus 1 is now 1 to the right. Just x squared minus 2 is 2 units to the right. Just x squared minus 8 is now 8 units to the right. What would I have to type in to make my equation go to the left? If I type in minus a number and it goes to the right, what would I type in to make it go to the left? I would type in plus a number, like plus 5. Actually moved it to negative 5. It does the opposite when it's inside the parentheses. And if we were in class, we could talk a lot about why that's happening, but we just don't have time to get into that conversation. So right now we're just talking about the fact that it does the opposite when it's on the inside. So again, here's my x squared. If I want to go 2 to the left, if I want to go to negative 2, I type in the opposite. I type in plus 2. And now it's 2 to the left. So here's a note for that, for the h value. Okay, h tells you how far you move your vertex to the left or to the right. X minus 4 means you move right 4. And x plus 4 means you moved left 4. So again, we're talking about inside the parentheses, this red letter H. And inside the parentheses, you wind up doing the opposite of what you would think. One way to think about that is if I wanted to get it back to 0, if I had x minus 4, I'd have to plug in a positive 4 to get back to 0. If I had x plus 4, I'd have to plug in a negative 4 to get back to 0. So h is always the opposite of what it looks like. So we're going to do a couple examples, then we'll come back and talk about what happens with this number out in front. So h comma k is my vertex. So here's a problem that I can do. We're going to graph y equals x minus 3 squared minus 4. And right now we're just going to find the vertex. You want to always find the vertex first. So we're going to find the vertex of this problem. I'm going to try to remember what numbers I used or what colors I used. I believe I used red for the inside. So this minus 3 on the inside is going to tell me that the x-coordinate of my vertex is going to be some kind of parentheses. The x-coordinate of my vertex is going to be positive 3. Okay, I have a negative 4 on the outside. The minus 4 on the outside tells me that I'm going to move my graph down 4 units. Oops. So my vertex is going to be at negative 3, positive 3, negative 4. So I'm going to put a dot right there. 3, negative 4. 3, negative 4. That's where my vertex is going to be. 3, negative 4. And if I graph this, I'm going to go to my Desmos and graph this. X minus 3 squared minus 4. So x minus 3 squared minus 4. Notice their vertex is at the point 3, negative 4. So that's where ours is, 3, negative 4. We went 3 to the right and 4 down. If we go back and look at our notes, we said when it's the h value on the inside, x minus 4 means move 4 to the right. So we had x minus 3. We moved 3 to the right. And then we had that plus k number at the end. So we had a minus 4. So we went down 4. We're going to do the same thing on this one. Vertex, find the vertex first. Okay, my vertex is going to use the numbers in the top, right? We're going to use this number first, and we're going to use this number second. So think about what that would be. Okay, if you said negative 2, comma, positive 6, you are correct. Negative 2, because I went 2 to the left. Positive 6, because I'm going to go 6 up. We do the opposite of what's on the inside, negative 2, and then positive 6. So if I graph this one, x plus 2 squared plus 6, so plus 2 plus 6, we're at negative 2, comma 6. Okay, now we need to talk about how to find the rest of the points. This one actually takes a little bit of time. I'm going to go back to my original graph. So y equals x squared. And all right, I'm just going to go through it. I'm debating whether to make a second video because it's getting long, but I think you guys just need to see it. So it doesn't matter if it's one video or two. So y equals x squared. We started at 0, 0. Let me show you some points that are on my graph. And actually, let's see, can I just make this into a table? Okay, so here's the points that are on my graph. Negative 2, comma 4 is on my graph. So is positive 2, comma positive 4. Because negative 2 squared means negative 2 times negative 2, which is positive 4. Positive 2 squared, I'm just plugging it in, 2 times 2 is 4. We'd also have negative 1, comma 1, 1, comma 1, and then 0, 0. And if I can add another point here, 3 goes up to 9. If I put in 4, go up to 16. If I put in negative 3, it would go to negative 9, or sorry, positive 9. And I'm actually going to capture this into my notebook. All right, so here's my graph. Now, again, what's happening is we are actually typing in numbers. So we're taking the expression y equals x squared, and we're actually making a table of values. So if we say, for example, x equals 3, that means that y equals 3 times 3, which is 9. If we say x equals -2, then we're saying that y equals -2 times -2, which is 4. And that's where all these points are coming from. So 3, 9 is right here. And -2, 4 is right here. You're actually plotting points on the graph. Okay, that's what's happening. Okay, so if you make a table, you're just plugging in numbers for x and you're finding all the values. We want to do that a faster way. We don't want to always have to plug in values because to get a good parabola, this good U-shaped curve, you're going to want 5 points. So one of the things you could do is you could plug in 5 different numbers to get the graph. But we want to do a faster way. So let me show you something. If I talk about slope, okay, if I look at the slope of each of these points, okay, the slope of this blue line, or let me show it another way, I guess. Here, let me get rid of these. If I go over 1 unit, this blue line is over 1, and this red line shows I went up 1. Then my next blue line, I went over 1. I'm going from 1 to 2. And to go up to the next point, it went up this many boxes, but really that's only up 3. If you look, this is going from 1 to 2 to 3 to 4. So 1 to 4, it only went up 3. If I go over 1, which is 2 boxes, each of my boxes is a half, and I go up to this one, it went up 1 unit, 2 units, 3 units, 4 units, 5 units. So we went up 1 unit to go from the first point to the second point. Then we went up 3 units to go from the second point, from the first point to the second point, sorry, or second to the third, if you count 0, 0 as the first. So from the vertex to the first point, we went up 1. To the second point, we went up 3. To the third point, we went up 5. And it's going to keep doing that because of a quadratic pattern. The quadratic pattern, because of the x squared, is going to go up by a pattern of 1, 3, 5, 7. And it does that on both sides of the graph every time we have an x squared. So I'm going to go back to one of our examples and show you what that looks like. Okay, we plotted the vertex. I'm going to put it back on there at 3, -4. So from here, if I were to go over 1, up 1, I'll get another point. And I can do that in both directions. Then I'm going to go over 1, up 3, let's get another point. And I do that in both directions. Then I'm going to go over 1, up 5, to get another point. And again, I can do that in both directions. This time I'll show it. Over 1, up 5. And then I have to connect all mine. This can be tough to do with a mouse. It should look more like a U than it does like a V. So x minus 3 squared minus 4. If I tried that, y equals x minus 3 squared minus 4. I'll put this into my notes so it's easier to look at. Whoops. All right, so we had our vertex at 3, -4. We went over 1, up 1. From there, we went over 1, up 3 boxes. From there, we went over 1, up 5 boxes, which actually goes off my graph because I only captured it up to 4. Other direction, over 1, up 1 box, over 1, up 3 boxes, and then the next one goes over 1, up 5. And that's a quadratic pattern. If, let's see, I think I gave you a table. Oh, I didn't capture the table. 1 squared is 1. 2 squared is 4. 3 squared is 9. 0 squared is 0. So that 1, 3, 5 pattern is actually coming from here. To go from 0 to 1 is 1. 1 to 4 is 3. 4 to 9 is 5. So we use a 1, 3, 5 pattern. The second example we did for the vertex, we had -2, 6. So -2 went left 2 and up 6. And we also have this minus sign out front. Remember the minus sign I showed you on one of the graphs at the very beginning? Means that we turn the graph upside down. So I'm going to go down 1 over 1 in both directions. Down 1 over 1. From there, again, my pattern is 1, 3, 5. I'm going to go down 1, sorry, over 1, down 3, or down 3 over 1. Then I'm going to go down 5 over 1. 1, 2, 3, 4, 5, 1. 1, 2, 3, 4, 5 over 1. And then draw my curve. That's my quadratic graph. Okay, so let's do a couple more examples. I'm going to show you how to deal with this with a number in front. That's one thing we have not looked at yet. I know this video is getting long, but we're almost done. Dealing with how to put a number in front. So the A represents how steep the rate is from one point to the next. You multiply A, sorry, let's make this the blue A, by the pattern 1, 3, 5, that same pattern we just graphed, to get the next point on the graph. If I show you that, if I just take my x squared graph, okay, there's my x squared graph. If I put a 2 in front, instead of going over 1, up 1, I'm actually going over 1, up 2. So now there's a point at 2, 0. Or let's see, sorry, I went over 1, up 2. And the next one, instead of 1, 3, 5, 1 times 2 is 2. 3 times 2 is 6. So I'm going to go up 6 from here. So 2 plus 6 gives me 8. And that's also on my graph. That's kind of hard to see. I'm going to show you on an example as well. A couple examples. We'll do a couple examples. Okay, so vertex first. Okay, vertex first. There is no parentheses, right? This is where my h would go. So there is no h number. That means it does not go left or right. We do have a -7 at the back, or at the end. So moves that up or down. It's down 7. We had that in pink when we were looking at our numbers. So my vertex is going to not go, it's going to, the parent function's at 0, 0. okay, right there. But my vertex isn't there. My vertex is not going to go left or right. It's just going to go down 7. So my vertex is right there. Okay, then I would use my 1, 3, 5 pattern. So normally I would go over 1 up 1, over 1 up 3, over 1 up 5. But I actually have this blue 2 in front. I don't know why I can't use my calligraphy pen. Doesn't matter. So blue 2 in front. Okay, so what I'm going to do with this 1, 3, 5 is I'm going to multiply it by 2. All these numbers in the pattern get multiplied by 2. And that's going to tell me what to go by. Sorry, I said 3 times 2 is 2. 3 times 2 is 6. Okay, so all these are being multiplied by that 2 at the very front of the equation, and that always happens. It tells you how steep it is, how fast the rate goes up. So instead of going over 1 up 1, I'm going to go over 1 up 2 on both sides. Instead of over 1 from there up 3, 1, 3, 5, I'm going to go over 1 up 6. So 1, 2, 3, 4, 5, 6. From the left-hand side, over 1, 1, 2, 3, 4, 5, 6. And then I would go over 1 up 10, but that's going to be way off my graph. So I can just call it a day with those 5 points. All right, last one, I think. Well, second to last one. My vertex is going to be at negative 4, 0. Okay, again, we do the opposite of what's in here. So that's going to be negative 4. There's no number outside, so it's not up or down. I just want to show you what the 1, 3, 5 looks like for this one. And maybe I even do 1, 3, 5, 7. I'm going to multiply it by negative 1/2. Okay, you can use your calculator for that. It might give you a fraction or a decimal. This is negative 0.5. The second one is negative 1.5. The next one is negative 2.5. And the next one is negative 3.5. So that means I'm going to go down. So starting at the negative 4, I'm going to go over 1 and down 0.5. So that's half a box. Just going to use a dot. From that dot, I'm going to go over 1 and down 1.5. So 1.5 boxes. From there, I'm going to go over 1 down 2.5 boxes. And then the reason I did 7 was because I know it ends in a nice number. If I go over 1 more down 3.5 boxes, it gets me to a nice integer. And that's my curve. Okay, and then you trace all those dots. The very last thing I wanted to show you, I know we're coming up on 30 minutes. There is problems on your homework that say to solve an equation. So here's what you do to solve an equation. I'm going to do this part in green. You take the number that's by itself and you make that a line. So y equals 7 is just a horizontal line. Okay, there's the 7, y equals 7. Then you graph your quadratic the rest of the way you've been doing. So this number inside tells me I'll be at positive 2. The number on the outside tells me I'll be at minus 1. So positive 2 minus 1 is my vertex. Then I would do a 1, 3, 5 pattern, but I'm multiplying that by 2. So all that stuff times 2. 1 times 2 is 2. 3 times 2 is 6. 5 times 2 is 10. So my points from here, over 1 up 2 on both sides. Then from there, over 1 up 6, 2, 4, 6. That hits my green line. I don't need to worry about the 10. And since I have an intersection of the green line and the black parabola curve, then my solution to the problem is those numbers. So x equals 0 is where that happened, and x equals 4 is where that happened. I'm going to highlight those. Okay, x equals 0 is where that happened, and x equals 4 is where that happened. So those are the numbers that you could actually plug into the equation to solve by graphing. All right, if you made it through this whole thing, 31 minutes, long video, thank you. Feel free to go back and watch the parts as you need to. There's really no way to make this shorter except to make lots of videos over the same lesson. Thanks, guys.